Hello everyone, it's Samir here, and today we will look at one of the past JEE advanced problems involving vectors. Okay, so the problem says that let O be the origin, and they have given us a vector OA, vector OB, and in terms of OA and OB, a vector OC is defined as OB minus lambda OA whole upon 2. Okay, and then it gives us that the modulus of OB cross OC is 9 by 2 and asks us which of the following statements are true. It's a multi-correct problem. Okay, so what we can do is we know OA, we know OB, so naturally our first task is to find OC. Okay, and they have given us mod of OB cross OC. So the instinct is in this equation, either we do a cross product on both LHS and RHS of OB or OC. So if you multiply, take a cross product of OB here, you will get OB cross OC, that we know it's mod here. This term will become 0. Okay, and here you will get OA cross OB. Okay, so OA cross OB we can find since we know OA and OB. Okay, so let's just start and see where it leads us to. Okay, so taking the cross product of this given equation, okay, with OB we get OB cross OC. Okay, OB cross OC becomes 0, and on the right hand side we get minus lambda OB cross OA by 2. Okay, now since OB cross OC, the mod of OB cross OC is given as 9 by 2, so the mod of this part will also be 9 by 2. So this part is mod of OB cross OA into lambda by 2 is 9 by 2. Okay, now we can find certain things such as we can find the mod of OA, mod of OB, OA dot OB. Okay, so we'll just try and find them so the picture becomes a little clear to us what are the given vectors. Okay, so now you can see that mod OA, it's 2 square plus 2 square plus 1, which is 9's root, which is coming as 3. So mod OA comes out as 3. Similarly, mod OB is 1 square plus 2 square plus 2 square, which is 9's root, it's again 3. Okay, now we take OA dot OB. Okay, so when you are taking OA dot OB, okay, so 2 we will get 2 here, and 2 into minus 2 you get minus 4. For dot product we will multiply i's with i's and j's with j's. Okay, and then plus 2. Okay, so your OA dot OB is coming as 0. Okay, here. So this has given us quite a very important information that first of all, mod OA and mod OB both are equal, both are 3, and OA and OB are perpendicular to each other. Okay, so triangle OAB is right angled isosceles triangle, and now it is very easy for us to find mod of OA cross OB. Okay, because the angle between OA and OB is 90 degree, it will be simply mod OA into mod OB. So mod OA is 3, mod OB is also 3. So mod of OA cross OB is 9. Okay, we don't need to do, cross multiplication between these two vectors using determinants. Okay, so you can directly find this from the given information and using this diagram. Okay, just try to roughly sketch OA OB in a 2D plane because they are coplanar. Okay, so you are going to get, see, this OA is 3, OB is 3, okay, and they both are equal as well as perpendicular. So OA cross OB would be just simply mod OA cross mod OB, which comes out to be 9. Okay, now putting this value 9 here, OB cross OA as 9, okay, we'll get the value of lambda as 1. Okay, now we put this value of lambda as 1 in the original equation given to us. Okay, so this will give us OC as OB minus OA upon 2. Okay, and OB minus OA is nothing but vector AB. Okay, so OC comes out to be AB by 2. So we try and construct OC roughly. Okay, so it will be parallel to AB and its magnitude will be half of that of AB. Okay, so it is parallel to AB and its magnitude will be half of that of AB. Now with this given information, finding the area of triangle OAB which was asked here becomes pretty easy. Okay, because since this is a right angle triangle, so angle of triangle OAB will be half into mod OA into mod OB. Okay, so mod OA and mod OB, this one we just put its value as 3 and 3. So it is 3 into 3 by 2, which is 9 by 2. So option B is correct. Okay, area of triangle OAB is 9 by 2. We can find from this information. Next, it asks us area of triangle ABC. Okay, so area of triangle ABC would be something like this. If we join A and C, okay, and you join C and B. Okay, so triangle of area of triangle ABC. Now you can see that since AB and OC are parallel. Okay, AB and OC are parallel and that both have same base AB. Okay, so triangle area of triangle ABC would be equal to area of triangle OAB because these are triangles between same parallels and same base. Okay, and same base because base of both is AB and AB and OC are parallel as we saw just now. Okay, so area of triangle ABC will also be same as 9 by 2. Okay, now we need to find the projection as well as angle between the diagonals of parallelogram. So projection, finding projection of OC on OA, it's pretty easy task because see OC it is half of AB. Okay, so you know that since this is 3, this one, and this is also 3, this is 3 in units, this is 3, so AB becomes 3 root 2. Okay, and OC is half of AB, so this becomes 3 by root 2 in magnitude. Okay, and these angles, this is 45 degree, this is also 45 degree. Okay, so its projection, this is also 45 degree. Okay, so its projection here you just have to take its sign, so it will be 3 by root 2. Okay, and multiplied by 1 by root 2, which will come out to be 3 by 2, and since it's in the negative direction of OA, so it will be minus 3 by 2. Okay, so the option given for projection was minus 3 by 2. Okay, so even option A is correct. Projection of OC on OA is coming out to be minus 3 by 2. Now the last part that it is asking is the acute angle between the diagonals of parallelogram with adjacent sides OA and OC. Okay, so the direct method to do this would be, you can write the vector OA is already given. You can write vector OC. Okay, and then maybe write their diagonals as OC plus OA and OC minus OA and find the angle between them. It's just little bit lengthy, that's all. But what we can do is, since all the vectors given to us are coplanar, okay, we assume all the vectors in xy plane. Okay, we are preserving their geometry completely, just pasting them on the xy plane. Okay, and we are putting A on y-axis, B on x-axis. Okay, like this. A on x-axis, B on A on y-axis and B on x-axis, with the coordinates of A would be 0, 3, B would be 3, 0. Okay, and since C it was half of AB, so it is going to pass through midpoint of OB, which would be 3 by 2, and since it's at angle 45 degree with the x-axis, so the coordinates of C would be 3 by 2, minus 3 by 2. Okay, so now we can find the slope of line AC. Okay, what we are actually trying to find here is the acute angle between the diagonals. This angle we have to find. Okay, so for this we need to find the slope of AC. Okay, so AC would be 3 minus 3 by 2 upon 0 minus 3 by 2. Okay, so this would come out to be slope of AC would come out to be minus 3. So coordinates of C are 3 by 2 and minus 3 by 2, and so the slope of AC comes out to be minus 3 and slope of OD will be 1. Why? Okay, because if we complete this parallelogram, D would be midpoint of AB. Okay, D would be midpoint of AB. So this line will go from origin at 45 degrees. Okay, so slope of OD is 1. So using the formula for finding the angle between two given lines, we use the formula tan theta is equal to m1 minus m2 upon 1 plus m1 m2, which is giving us tan of angle between these two lines as 2, while the option that was given to us says that the angle between them is pi by 3. Okay, so while so this is not correct, the angle is coming as tan inverse 2. Okay, so this won't be correct. Okay, so the crux of this problem was how we transformed a completely 3-dimensional geometry problem into a 2-dimensional geometry problem, because all the vectors given were in the same plane. They were not in the xy plane, but we transformed them into xy plane and used simple geometry to find our answers. Okay, so for more such problems, solutions and new ideas, keep watching further videos and see you in the next video.